All right, so as it says on the screen, there are two signs that you might be familiar with if you've ever done any programming, or you might not. And those are the two equal signs and the not equal sign. So exclamation mark equals means not equals, and two equals means equals. So let me make a new. So if I have an integer, right, and I want to set it equal, you can think of one equal sign as becomes equal to, and two equal signs as is it equal to. But this is going to print out the word true.
You're still just sharing the CS Awesome screen, by the way.
Thanks.
Yeah, better.
So one equal sign means becomes equal to. Two equal signs means is it equal to. So two equal signs will always give you a true or false statement. One equal sign is always true because, well, usually true because you can set something equal to something else. And if you can, it will usually give you a Java error. But anyway, point being, one equal sign becomes equals to, two equal sign is it equal to. So true, false, right? So in your mind, I want you to predict what this program is going to print out. You don't have to say it out loud. I'll give you like 10 seconds to look at it and figure it out. All right, so we set x equal to 5. We say, is x equals to 5? Is x equals to 6? Is x not equal to 5? Is x not equal to 6? So it's going to print out true, false, false, true. Because x does not equal 5 is false. X does not equal 6 is true. I'm going to go ahead and assume that you are already familiar with the relational operators, less than, greater than, less than or equal to, greater than or equal to, because I think all of you have taken math class. The modulus operator is something that you will see a fair amount of. And that is because it is a very useful tool. For those of you that don't remember modulus, it's exactly the same word as remainder. So if I have 112 modulus, let me just print it out. 20. What do you think that's going to print out? We already know what 112 divided by 20 will print out. So in the chat, just tell me what you think these two lines are going to print out. The bottom two lines here. 112 divided by 20 and 112 modulus 20. Go ahead and type it in the chat. All right, so Eric, why do you think it's going to print out 5 for this line right here? Because it's integer division. So it doesn't care about the decimal. Yeah, it should be 5 point something, something, something. And if we did 112.0 divided by 20.0, it would give us those something, something, somethings. But we didn't. So integer division always drops it, even if it's 5.99999999999, right? Even if we did 119 divided by 20, it would still only give us 5. It doesn't round, it just cuts it off. All right. Zoe, why do you think it's going to give us 12 for the second line?
Because the nearest multiple of 20 is 100, so 12 would be the remainder.
Exactly. Yep. So if you remember long division, right, you have that long division symbol, you go through it all, you end up with 5 times 20 is 100, the nearest multiple, like Zoe said, and then you end up with 12, and you can't do anything with it. That's the remainder. So it's going to print out 5 and 12. So here is the question. I'll give you, don't type it in the chat yet. I want to give you 10 seconds or so. How could I tell using the modulus operator if a number is even or odd? So wait a few seconds before you type it in the chat. How can I tell whether a number is even or odd? Okay, so we have a couple answers in the chat. So to use the modulus, we have a couple answers. Where did I go? What happened to my REPL? Oh, there it is. Okay. Have a number 1, 2, 3, 4, 5% 2. Right. So what we're saying is, if we take a modulus with 2, what's the remainder? If it's an even number, right, the remainder will be 1. If it's an odd number, the remainder will be 0. So Zoe had a good idea. We can even make it true or false if we say, is this equal to 0? It'll say true because it's even. This will say false because it's odd. So if the remainder is equal to 0, it'll print out true, which means yes, it's even. And you can do the opposite if you want to find out if it's odd, say not equal to 0. Either way, it's going to work. So that's how modulus works. Really, really useful. And you're going to see it a lot because they do a lot of even odd things, stuff like that. If and else statements are I think the closest thing to English that Java has. So the way that they work is literally you use these Boolean statements, true and false, to do stuff. So if I want to know if a number is even, here, let me do it this way because this will be. If input number sent to is 0, like Zoe said, if I run this, it doesn't say it's even because I have an input number that equals 1, 2, 3, 4, 5, and I say if the input number modulus 2, if I divide it by 2 and the remainder is 0, then it must be even. So print it out. I can be even fancier by saying else it's odd. And a little. All right, so at the bottom here, it prints it's odd because 1, 2, 3, 4, 5. If the remainder is 0, print it's even. Else, print out it's odd. So if I 1, 2, 3, 4, 5, 6, it'll print out it's even. So these are literally, I think, the most English-like statements. Let's actually do this. It'll be more fun because we can use the random. So run this a bunch of times. And it's giving me even and odd numbers. So this is the type of question you might get on a quiz, right? Get a random number and tell me whether it's even or odd. That would be a pretty common question on a quiz. They also go through some of the common errors. You guys, I'm sure, have had errors with forgetting a semicolon. Right? It's really common to forget those squiggly brackets. And it can give you like this weird illegal start of type error. What does that even mean? Right? Why can't it just say you forgot your squiggly bracket? So just be careful. One really common error too is using one equal sign where you meant to use two equal signs. Unexpected type. What does that even mean? Oh, it means I forgot to use two equal signs for is it equal to. All right, so the last thing that, I think it's the last thing for this part. Let's see. Yes. So the last thing for 3.3 Unit 3, 1 to 3.3. So the last thing that we are going to go over is if, else if, and else. Oh, 1 second. Mary Beth, I'm going to put you in a different breakout room. There are a couple of people working ahead.
Okay. What section are they on? So I have it pulled up.
Probably, I'm guessing 3.5.
Oh, wow. Okay.
Yeah, so let me just try to get over there. Did it invite you? Oh, you know what?
Am I supposed? I was already invited to breakout one. Should I?
Yeah, that's the one.
That's one. Okay, I'll go there.
Great. All right. Oh, this is 3.4, sorry. 3.4. And let me paste it in the chat. I pasted these examples in the chat. So if you want to follow along or you want to save them for later, you can. I'll also put them in Google Classroom. Okay. All right, so multi-selection. We're going to need a little bit more math for this example. So this is good for if else. Now, if you remember IT launch, we actually did this in Python, where it asked you how many hours a day do you spend on the computer. So I'm going to introduce you to something called the scanner, which allows you to get input from the user. This is not something that you need for the exam. This is not something you're ever going to be tested on. But it just makes stuff more fun because you can actually get, input from the user. So this is how you create a scanner object, and all a scanner object does is a way to get input. Again, you're not going to be tested on this. You don't need to memorize this. We're going to say, how many hours a day do you spend on the computer? Okay. And then we're going to say hours equals this. So it's going to get the next integer that the person types in. So let's just run this to make sure it works. It doesn't. I forgot to import. And don't worry too much about how the scanner works. But you can see now it's asking me how many hours a day do you spend on the computer? And if I type in something, it doesn't do anything with it, but at least it works. We know it's scanning something in, and when I type in something that's not an integer, it doesn't like that because it's asking for the next integer. So again, we're not going to worry about, we're just going to assume the user is going to type in an integer. Because we want to check this hours to see how long they spend on the computer. You spend hours. So if I type in 123.4, it says, right, it stores it in this variable called hours, whatever I type in. All right, so what's a reasonable amount of time to spend on the computer? Let's pretend we weren't on the computer all day long. Somebody type in a number of hours in a normal year that seems reasonable. 2, perfect. So if hours less than 2, that is great. Let's try it a few times. How many hours a day do you spend on the computer? 66. You spend 66 hours on the computer. If I say 1, it prints out, that is great. So we already learned about else, so we're going to say else. You spend more than that, right, or equal to that, because the opposite of less than is greater than or equal to. The opposite of less than is not greater than. It's greater than or equal to. Else print, you need to get outside more. So if I spend 8 or 7 hours a day, it says you need to get outside more. So what if I want more options though, right? What if I say between 2 and 4 hours is not great, but you know, you must have a lot of homework. Well, the way I do that is I just say else if hours is greater than or equal to 2, oh, sorry, hours is less than 4. Because we already know it can't be less than 2, because if it's less than 2, it'll go in here. If it's not less than 2, it keeps going down all these other options. So if it is less than 2, it prints this out and skips the rest. It doesn't check anything else. If it's less than 2, it does this and then forgets about the rest and goes to the end. So we could say you probably had a lot of homework. So even though if I type in 1 is less than 2 and it's less than 4, it checks this first, prints this out, and then skips the rest. It doesn't check anything else. The first thing it finds that is valid, it will do that. So let's try it. How many hours spent? 1. That is great. Again, even though it's less than 4, it never gets there. It never checks it because this was true. If I run it again and I say 3, right? It doesn't do this because 3 is not less than 2. It does do this because 3 is less than 4, and then it jumps out. And I can put as many of these in as I want. I can put in 100 else ifs if I want. So whichever one it falls in, it'll do that and ignore the rest. It'll check them in order. So if I type in 5, it'll skip the first 2 and do, did you watch a movie? If I do 7, it'll do that. And if I do anything 8 or more, it says you need to get outside more. All right, so how are we feeling about Boolean statements, which are just means true or false statements, if statements, else statements, and if and else if? Give me a plus, a minus, or a squiggly. All right. This is great. 2, 4, 6, 7, 2, 4, 6, 8. So 4 people didn't answer. Tony feels good. Cole. Della feels good. Kyler, how are you feeling about this? And Zachariah, how are you feeling about this? Okay. Awesome. So basically for the rest of today, I want you to get as far as you can through, what did I assign? 3.1 through 3.6. Okay. All right, well, let's get through 3.4 at least. I think you guys are going to blow through that pretty quickly.